presentation.
Yeah, okay.
Yeah, so let me just introduce our next speaker. So we have Professor Martin Chu, a member of the Hong Kong SAR Government's Committee on Green Technology and Financial Development, and also the co-founder of iQtools Limited, which is a very innovative company producing many innovative products relating to our green energy solutions and innovative solutions for smart and sustainable cities. So let us invite Professor Martin Chu for the next
Yeah,
session
thank
of
you.
the webinar.
Yeah, thank you, Americana, and thanks, Dr. So, for the introduction to the smart civil engineering, material, and technology. So please allow me to share my screen. And this is about what we are doing in the energy efficiency utilization. And can you guys see my screen?
Yes, we can see it.
Yeah. Hello, everyone. My name is Martin, co-founder of iQtools Limited, and we are doing electricity free cooling technology to save the energy for air conditioning system. And the reason why we conduct on this application is because you know that the global warming and the climate change are very serious issues in the past few decades. We are recording a very high temperature environment, and the temperature trend is going up. And this will cause a lot of serious issues. For example, we need to turn on the AC system and consume more energy for cooling the indoor environment, and most of the outdoor equipment, they will suffer from the low energy efficiency in a high temperature. And we also got a lot of climate change refugees, especially in those countries without enough energy supply to create a good thermal comfort in summer, for example, India or Africa. Yeah, so this is why we are very urgent to have a new cooling technology to solve the issues. And you know that in Hong Kong, we are in Hong Kong. Hong Kong is a city that is very hot and humid because we are close to the equator. That's why we are hot. And we also have a very monsoon situation in some seasons that we are humid. That's why in Hong Kong, we spend most of the energy in the air conditioning system to improve the thermal comfort. And also Hong Kong is very high density city. And you know that Hong Kong has more than 7.4 million people in a very small urban space. And you can see that the total landfill area in Hong Kong actually is a lot small, but we just have 50% of the landfill is designed for the urban development, which means that 50% of field is just the area for the leisure, for the park. Yeah, so that's why it's very constrained area for everyone to live in. And we have a lot of high-rise buildings because we have many people live in a small constrained area. So that's why we have more than 50,000 high-rise buildings. You can see that when we sum up the length of all the buildings in Hong Kong, that will be the 40 times of the length of, and also the 6 times larger than the distance between Hong Kong and Macau. You know that the Hong Kong and Macau, we have a very long bridge to connect, but if we sum up all the length numbers of the buildings in Hong Kong, you will be the 6 times of that very long bridge. And in Hong Kong, from the data of the government, the the electrical and mechanical service department in Hong Kong, around 27% of the electricity in Hong Kong is consumed by the residential buildings, while the remaining energy is consumed by the commercial buildings. And you know that in Hong Kong, most of the people will stay in indoor environment, like for living, for shopping, and for schools. Most of the time, we are staying in indoor environment, and that's why the buildings would consume like more than 90% of the total electricity in Hong Kong. This is very significant numbers. And you know that in this building, in this building, you can see that around 30% of the energy in the buildings is consumed by the air conditioning system because discussed. Yeah, that's why if we can mitigate the energy costs for the AC system in Hong Kong, that will be very useful for us to contribute to the carbon neutrality of the whole city. And this is why we're going to find a very good a universal cooling solution to mitigate the heat island effect or also reduce the carbon emission from the buildings with cooling material, because the building consume most of the energy in the air conditioning sectors. And our research team wanted to do so because we want to solve the issues of carbon emissions in Hong Kong. And around 7 to 8 years before, it was very interesting. Was that the research team of us, we traveled to the Middle East, and in the Sahara Desert, we discovered there was a silver ant that can survive in a very hot environment. The temperature will goes up to like 70 to 80 degrees Celsius. And the silver ant can still survive in the desert. And after going back to Hong Kong, we was very curious about why the silver ant can survive. And finally, we found out this is because the radiative cooling phenomenon on the surface structure of the silver ant. And actually, in our daily life, there are some similar phenomenon that can create a similar effect. For example, when we go hiking in the morning, I'm not sure whether you guys go hiking in the morning. And when you go hiking in the morning, like in summer, not in the summertime, but like spring or autumn or winter, you may see some frost on the leaves in the very early morning. This is also because of the radiative cooling phenomenon that can create the cooling effect on the surface of the material. Then the water droplet in the air will just become the frost in a low temperature, and also making that the solid state of the water content on the surface of the material. And this is the reason why the silver ant can survive, because of the radiative cooling phenomenon. So generally speaking, it can reflect most of the solar energy from the external environment. For example, the UV light and the visible light and the near infrared light. These are the energy from the outdoor environment, from the solar. This is the external phenomenon that potentially can heat up the silver ant in the desert. Then the silver ant will reflect this incoming energy. And the second part is that the silver ant itself, the body energy generated heat. Then the surface structure will convert the body heat into 8 to 30 micron wavelength. So why it focus on 8 to 30 micron wavelength? It is because of the phenomenon of the atmospheric windows. And you know that the atmosphere is like actually like a thermal insulation layer to the Earth, and it will protect the Earth from losing the heat to keep us warm. But this atmosphere will just allow the 8 to 30 micron wavelength to pass through. So that's why if the silver ant can convert the body energy into this wavelength, then the radiation can just carry out the heat and just go into the cold universe. The universe temperature in the outer space is just like absolute zero minus 270 degrees Celsius, so that the silver ant, it can just facilitate a heat transfer by utilizing the great temperature difference between its body structure and the outer space by the 8 to 30 micron wavelength. So this is the reason why the animal can just carry out the heat and dissipate out to the outer space environment to keep its body cool. And with this very, very smart strategy for keeping the body cool, and then we apply the working principle into the material. For example, the coating for the rooftop and the external wall, and also the film for the windows, and some other material for our daily applications. And actually, the heat transfer models, we are having three very general models. One is the conduction. For example, when you contact something very hot, then your hand maybe feels the heat. This is because of the conduction. And when we heat up the water, and you can see that the temperature in the water is not very distributed evenly, but hotter, closer to the heating source. This is because the conduction. But eventually, you know that the whole water body will just get boiled, because the hot water will goes up and the cold water will goes down. This is what we call a convection. And the other one is that when you get close to the fire, you didn't touch the fire, but you can still feel the heat from the fire. And this is due to the radiation. And just back to the heat transfer model we are discussing here, the energy transferred by 8 to 30 micron to the universe is just due to the radiation. Yeah, because the silver ant surface skin, it doesn't need to touch the outer space, but it can still carry out the heat from the body energy to the outer space by 8 to 30 micron, the wavelength. So this is what we call the radiative heat transfer model here. Just like when you get close to the fire, you don't have to touch the fire, but you can feel the heat. This is also due to the radiation. And Then, based on this heat transfer model, we can actually identify the way that we can lower our indoor environment temperature. So the first of all, by the conduction, and then we can get the energy from the hot area to the cold area, or by radiation like the silver N. This is what we call the passive heat transfer method. And the other one is that we actively move the heat from the hot environment to the cold environment, just like in summer when we turn on the AC system. Then this is like an active method of the cooling strategy. So what's the problem of the active cooling here is like, when you remove the heat from the colder space to the hotter space, you need to input the energy because otherwise it will violate the law of thermodynamic, the heat transfer. And then it will create the environmental impact because when you turn on the air conditioning system, it causes the electricity, it will cause the carbon emission, and it will also emit some, the global warming gases due to the refrigerant inside the air conditioning system. And it will also has a very complexity and a maintenance cost because you have to maintain your air conditioning system in a good condition, like to check whether the refrigerant leakage, etc., etc. Very complicated. It will create the noise. Like when you are using some old version of the air conditioning system, it will create some noise when you turn it on. Yeah, that's why there were a lot of problems for the active cooling. And the solution is that we would like to avoid using active cooling strategy in some new building design because the passive way is like you don't need to input the energy, but you can carry out the heat to the outer environment. That's why it can create a very sustainable cooling strategy for the buildings. And actually, the radiated cooling we discussed by the Sahara Silver N is kind of a passive way of the cooling strategy. And in 2023, our research team has published this technology on Science. You know, the Science and Nature are two best scientific journals in the world, and we publish on Science. And I really hope that you guys later on can also go into the STEM direction and publish more interesting or exciting research paper on Science or Nature. Yeah, I believe that all you guys can do something similar in the future. And actually, this is also a recognition from the community of the scientific research. And with this technology, we apply to many of the infrastructure of our city. For example, the building or some other equipment that require the cooling. And basically, we optimize the nanomaterial structure with the silver N structure working principle and put into coating, film, ceramic, or even the textile for everyone's wearing, and the paint for the vehicles, because the vehicles, they just park the car outside and we will suffer from the heat during summer. And you can see this is one of our commercial case in Hong Kong, a shopping mall in Hong Kong. And when we apply the material on the rooftop, you can see that the surface temperature reduced by more than 30 degrees Celsius, and around 42% of the energy cost for the AC system has been saved. So to the owners of the building, they can save the energy. They can save the fee of electricity. And the cost saving will just take like 1 year to cover the cost of application. For example, the material cost and the manpower cost for applying the coating on the rooftop. So the payback period is just 1 year. Then it's very important to highlight that the new technology cannot be very expensive. Otherwise, the owners of the buildings would not willing to use your technology because it's difficult for them to justify the cost. And that's why we have to keep the payback period as short as possible. And the other case is the film case we apply to the hotel. You can see that with iFilm and without iFilm, the color difference are not that much, but we can still reduce around 15% of the cost for the whole hotel. And this is the hotel in Cheung Kwan O in Hong Kong, Crowne Plaza. They also get a very good payback year, and they also got recognized by the Industry of the Year Award by using our new technology into the energy saving strategy of their property. And yeah, and we also did a very good case, very large one in the Hong Kong Coliseum. This is a very famous venue. You know that the famous superstar in Hong Kong, like Anita Mui and Leslie Cheung, they also took the concert in this venue. And we applied to the whole rooftop and can save more than 30,000 kilowatt hour per year for the government because of the lowering cooling load of the venue. And we also apply to many of the applications like to cool the outdoor equipment, and also in Dubai, in Abu Dhabi, and in some outdoor energy storage facility to improve the charging and discharging efficiency. Because just like your phone gets hot, then the efficiency goes down. And actually same as the outdoor equipment. So that's why we apply to that. And we also apply to some outdoor chemical storage containers to reduce the evaporative loss of the material and to improve the storage efficiency. And we apply to many of the countries, not just in Hong Kong, but you know, the Middle East and the Southeast Asia, they are hot countries. And maybe some of you guys are from that countries, and maybe you guys can share a little bit about your experience in your countries and how do you feel like the global warming trend will changes light in your local countries. And yeah, and later on we are applying to the textile for the thermal comfort in the body, different application like your t-shirt, your jacket, and your sporty clothes and umbrella and the tent. And we can see there are very significant temperature reduction as compared with other brand of cooling textile, because we combine the cooling textile with the radiator cooling principle to further reduce the body temperature. And vehicles, like we are working with some manufacturers of the vehicle to provide the cooling and also the ceramic block that we can apply to the infrastructure and many of the places in our city. And we also got some recognition from the industry, from the government to recognize our achievement. And most importantly, we are not just doing the business project, but we are also doing some free community action project to the low-income family, like in Shamsherpur area in Africa, in India, to improve the thermal comfort for everyone. And I really hope that later on, maybe you guys can also participate in the SDG initiative. And if you're interested in joining our volunteer trip later on, then that's just feel free to contact me, and let's work together to promote the carbon neutrality for everyone. Yeah, thank you.
Thank you. Thank you, Professor Zhu, and thank you again, Dr. So. Thank you, the two speakers, for a really amazing speech, which demonstrated to us many different kinds of innovative technologies, and from different angles and different perspectives that the students who could explore if they are interested in. And first of all, really appreciate your speech and your time and your effort, commitment to delivering this speech. And secondly, because we still have a bit of time left, let's see if the students have any questions. I have now enabled the chat function to see if students are have any questions. You can now send in the chat room. So please,
Yeah. Just feel
please, I
free to
do want to,
ask
yes.
any questions.
Please, I do want you guys to keep the chat room limited to relevant contents. And yeah, if you have questions, please, now it's your chance to ask. So maybe I will start with the question to Professor Chu. So what do you think, can you give any recommendations to our students when they are thinking about giving innovative solutions? So
Yeah, I think to the I mean the climate change, I think everyone can actually take the action because when we are talking about the energy saving or sustainability, we are always focused on some very big topic like the policy of some countries or some very big movement of the big corporate to take actions to the climate change. But actually, everyone can also contribute ourselves, just like in your daily life. You choose the lifestyle of consuming less energy, or choose the product that has less carbon emission. For example, the local product instead of the import product to save the carbon footprint during the transportation. And also, it's very important to eat more vegetables, like because the agriculture, like the animal will emit the CH4, the global warming gases. That when you are having more vegetables, then it also contribute to the environment. So yeah, a lot of very actions then can be taken by everyone. And yeah, and just in the chatbot, I saw that yeah, a student mentioned that cut down on the power of the changing environment instead of reducing the temperature rising, and then we can solve the climate change problem by stop producing greenhouse gases. Yeah, I think this is a very a good insight, because when we are still producing more greenhouse gases, it's very difficult for other people to cut on their own emissions, because everyone actually should contribute our own effort or our own actions to stop the world from being heated up once again. And yeah, and I think stop producing something new is very important, or get well utilized of what we have existing, like we don't just over consuming, like you buy something what you don't need. This is why we are consuming a lot of energy or electricity or resources, just like everyone just buying something they don't need. And to just think over what you have, and really if you really want to buy those materials or things before you take the action. So it's very important to have a good saving living style. Yeah, and I also
We have a
saw
good
another.
question. So we have
Yeah,
Moses who
yeah,
asking,
yeah.
is it possible to persuade big fashion
Mm.
companies to make use of the cooling materials, or even through like national legislation to use the bare materials?
Yeah. I think we are actually selling our textile material as I presented in the slide to some fashion brand, because we can create the textile to improve the thermal comfort of the audience, that the people can just buy the clothes, then they can have a better experience in summer. Yeah, so indeed we are selling, for example, in this summer there is a brand. I think there will be two brand in mainland China. One is the UR, another one I cannot say at the moment. Yeah, they will adopt our cooling textile to launch in the summer as one of the series in the polo t-shirt. And this is one of the way we are promoting the green technology to improve the thermal comfort of the public. Then maybe people can have a cooling textile on the body, and then they can turn less, turn on the AC in a higher temperature setting point, then it can also save the energy. And by national legislation is also one of the method. And in this way, for example, in mainland China, when we promote the green technology to the buildings, then they may not be interested in using the energy saving technology for some building owners, because the whole property they just lease out. The energy cost is burdened by the tenant instead of the owners. In this way, the owners are not interested to taking any action, because the saving does not go to their account. So in this way, some countries they take some action. Say they, sorry, they pass the law of some of the buildings they should adopt the green technology to their facade, like in Singapore. It is a must for the buildings in Singapore to have a high reflective material on the facade of the building. So something like that, yeah. And in this way, we are combining different methods. One is to actively engage with some big corporate. Another one is to engage with some government. Then they can combine the cooling technology or some other sustainable technology to their existing infrastructure.
Thank you, Professor Chu. That is a very inspiring and also very detailed answer for the students. And let's see, do we have any other questions in the chat? If you do have, you can ask
Yeah, maybe the
any
student can also
question.
turn on your mic, yeah, to share yeah, to share your experience in your own country, like how you experience over the past few years. Is it getting hotter and hotter in your home country due to the climate change? Yeah, you can just feel free to share.
Yeah, or if you have any question that you want to ask Dr. So, you can also ask right now, or if you want to ask me for my first section, because we also didn't have a Q&A session. So any question you want to bring up, feel free to do so. So regarding the SDG and so we have a question. Is it possible to let everyone use green materials in their construction? So maybe regarding green construction, you can, I think for this question, Professor Chu and Dr. So can both have some maybe discussion and contribution. We can have,
Uh,
as it's directed
yeah.
to Professor Chu, we can have Professor Chu first.
Yeah, and yeah, I think it is possible because the green materials are related to everyone's daily life and not just the textile or some other electronic devices I mentioned, but also in the construction industry. And just like in the construction, when we use the green material, we are saving the energy costs. Like in the construction site, we have some containers that the workers or manpower who are living in the container in summer in Hong Kong, the container temperature are super hot, and then they need to turn on the AC system, then it will cause the energy loss due to the temperature controlling. So that's why if we can apply some green material to the construction site, like those kind of containers, then I think it also helps to save the energy. So I think it is possible, yeah.
So maybe Dr. So, are you still here? Do you want to have any inputs on this question for the green
Uh,
materials on the construction? Or the second one, we also have, can we use hydrogen to replace our energy source? Any question that you feel like answering?
yeah, for green materials, I think depends on the design loading. So what I'm trying to say is, for example, like high-rise building, you never see we use concrete to build the high-rise building because the self-weight of the concrete is much greater than the self-weight of the steel bar or the steel. So the key of using the green material depends on the strength of your material. So if you say your green material is sufficient to use for pavement and then for the long structure used for the partition wall, I mean the non-structural component, then of course we can use all those green material and then for the constructions of the building or other infrastructure. And but if you are saying you are trying to make a high-rise building, then your green material should have sufficient strength to resist the wind loading or the dynamic loading. So it depends. But of course, at least we can use the green materials for non-structural component like pavement, partition walls, and also those precast unit for the landscaping. Yeah.
We also have a question regarding shortcomings in environmental friendly materials. Maybe we can take that one. Professor Chu or Dr. Su, if you guys wanna take this one. So any shortcomings in the environmental friendly materials?
I think I encounter several questions from even our investors. Sometimes they will ask, you use those ways. Is it possible we have a lot of heavy metals in those so-called green materials? And of course, I haven't conduct a very comprehensive test lab or laboratory test for verifying the amount of the heavy metals in our green materials. But at least physically, we can imagine as long as you can bind those waste together. So the heavy metal inside those waste are also physically trapped in the material. So I don't think we we may cause some environmental pollutions when we use the green material. And but maybe one shortcoming, major shortcoming is you need to design for a particular strength for your material. So we may not be able to achieve a higher strength as a concrete. So this may be also a shortcoming. So we use green material, but maybe the strength is not that strong compared with conventional material. Yeah.
Maybe we can take a last question. I think this one is particularly very good. So we have, how can smart infrastructure ensure equitable benefit across diverse social groups? So just linking the innovative environmental technologies to the social side of sustainable development. Does Professor Zhu or the Terso want to take this question?
Maybe Professor Marty can share his view. Yeah. Yeah.
Yeah, please.
Yeah. I think yeah, this is a very good question because when we are talking about a new technology or new applications, we couldn't just focus on the profit or the income of the technology that can generate. We also have to consider whether the people can get the benefits from the new technology. And I think this is way more than the technology itself, but how you use the technology. Just like in our case, our electricity-free cooling material. In general, we apply to some residential or commercial buildings or infrastructure to save the energy for the building owner, but we can still apply to some low-income community. For them to improve their thermal comforts. But the way is that we have to figure out that if we don't earn the money, then who pay for that? So at the very beginning, when we did the technology transfer from the lab to the product, we are also looking for many of different types of the funding source, some from the government, some from the investors, and some from some NGO or community charity group. And for some of the project we are ongoing was about applying to the Sumshui area. And at the very beginning, the reason why we did such kind of project was because actually, like in my childhood, I also live in some similar environment of the some triple old buildings. So that why in 2022, I saw a news on Hong Kong 01. It was talking about like a very old building. There were 4 people living in a less than 200 square feet, very small house, just like what we said, these subdivided houses. They're living 4 people in a very small area, and the daughter of the family just got very hot, and she didn't want to go to school because of the hot environment, and she got some mental issues. And at that moment, we took action immediately to apply the cooling material to the rooftop for free. And because of the limited resources at that moment, we can just apply to a one very single subdivided houses. But after that, some NGO and community organizations, they saw the cases and they were, wow, this is very interesting and helpful to our subdivided house and underprivileged families, and they decided to help us to do the project larger. So currently we have applied to more than around 500,000 people's houses to improve their thermal comfort with their support. Yeah, so I think it's very important that to have our mindset is that if you invented a new technology, you own the IP, of course. Earning money is important, but the way more important is that your technology or your IP can really be applied to the society to improve the living quality or the life of everyone. Yeah, I think the mindset is way more important.
Thank you, Professor Chu. That is very inspiring, and also just linking to the SD